Hello friends, welcome to all of you Dr. JD's Academy. Today I am going to start chemical properties of phenol. So actually phenol shows three types of chemical reaction. Number one is reaction of phenol due to OH group. So this one. Second one is reaction of phenol due to benzene ring. This is the aryl group. And third one is a naming reaction or special reaction of phenol. So in this video, I will discuss only the chemical reaction of phenol due to a OH group. So phenol shows a different types of chemical reaction due to OH group. So phenol, they are react with the number one is alkyl halide, second one is zinc dust, third one is ammonia, fourth is acid chloride or anhydride, fifth one is benzoyl chloride, and the last one is the reaction of phenol with Grignard reagent. So first I will start the reaction of phenol with alkyl halide. So actually the alkyl halide reacts with the sodium phenoxide. So in this case we have to convert first phenol to sodium phenoxide. So how does it take place? So phenol, here we have a phenol that reacts with the sodium hydroxide. So in this case, H positive from the phenol and OH negative from sodium hydroxide combine to form a water, and this sodium ion is attached to this phenolic oxygen to form a sodium phenoxide. Now this sodium phenoxide reacts with the alkyl halide. So here I am taking alkyl halide is methyl iodide. So in this case again, this is a sodium ion, positive ion that combines with the iodide ion to form a sodium iodide. And the remaining, this is CH3 positive, there is attached to this oxygen to form a ether. And this compound, the name of this compound is known as, this is a anisole or methoxybenzene. So this reaction is used for the conversion of phenol to ether. And this reaction is known as Williamson synthesis, which is used for the preparation of ether from the phenol. So second reaction is the reaction of phenol with the zinc dust. So here we have a phenol that reacts with the zinc dust in the presence of heat. So in this case, this is zinc combined with oxygen to form zinc oxide, and the remaining moiety is benzene. So this reaction is used for the conversion of phenol to benzene by reacting it with zinc dust. Third reaction is reaction of phenol with ammonia. So here we have a phenol when it reacts with the ammonia in the presence of anhydrous zinc chloride. So in case of ammonia, this is H positive and NH2 negative moiety. So this is OH negative of a phenol combined with H positive of the ammonia to form water. So here we form water, and the remaining NH2 group, they are combined with this phenyl moiety to form a aniline. And this reaction is used for the conversion of phenol to aniline by reacting it with ammonia in the presence of anhydrous zinc chloride. Fourth reaction is reaction of phenol with acid chloride, or we can say that acid anhydride. So in this case, the H positive of the OH group, means phenol, is replaced by, that is the acyl group, RCO group. So here we have a phenol when it reacts with the acid chloride or acetyl chloride in the presence of pyridine. So in this case of H positive of the phenol combines with the Cl negative of the acetyl chloride and eliminate in the form of HCl. And the remaining, this is CH3 CO group is attached to this oxygen to form, this is the phenyl acetate, which is the ester. This is the phenyl ester. So in this case, the H positive of the phenol is replaced by acyl group. This is RCO group, acyl group. So that is why this reaction is known as acylation, because due to the replacement of hydrogen atom with the acyl group. The similar reaction is shown by acid anhydride with phenol. So here we have a phenol when it reacts with the acetic anhydride in the presence of pyridine. So acetic, the structural formula of acetic anhydride is this one, CH3COO-COCH3. So in this case there is a cleavage of, this is COO bond. So this is the cleavage of COO bond. So due to cleavage of COO bond, this moiety, that is CH3COO, they are combined with H positive of the phenol to form acetic acid. And the remaining moiety of the acetic anhydride, which is CH3CO, is attached to this phenolic oxygen to form again ester. And this compound is known as phenyl acetate. So in this case again, H positive, that is a hydrogen positive of the phenol, is replaced by, this is a acyl group. So that is why this reaction is known as acylation. Next one is, that is the benzoylation, or the reaction of phenol with benzoyl chloride. So as the name indicates, benzoylation means that is the hydrogen atom of the OH group is replaced by benzoyl group, C6H5CO. So here we have a phenol when it reacts with the benzoyl chloride in the presence of sodium hydroxide. Then H positive from the phenol combines with Cl negative of the benzoyl chloride to form HCl, and the remaining group, that is C6H5CO, is attached to this phenolic oxygen to form again ester, which is known as phenyl benzoate. This reaction is used for the conversion of phenol to ester, either by reacting with acetyl chloride or acetic anhydride or benzoyl chloride. So in this reaction, hydrogen atom is replaced by benzoyl group. So that is why this reaction is known as benzoylation. And another name of this reaction is Cotton-Bowman reaction. So in acylation or benzoylation, we get two main products, that is the phenyl ester. So when the phenyl ester, either phenyl acetate or phenyl benzoate, when it's further react with the anhydrous aluminium chloride, then this phenyl acetate or phenyl benzoate, they undergo rearrangement. So in this arrangement, in this case, this is the acyl group, CH3CO. Acyl group, they are migrates from the phenolic oxygen to the ortho position or para position. This acyl group migrates from phenolic oxygen to the ortho position or para position. When it migrates to the ortho position, then we get a product that is ortho hydroxyacetophenol. When this group is migrated to the para position, then we get a product is a para hydroxyacetophenol. So during this rearrangement, the acetyl group either migrate to the ortho position or para position, and we get a mixture of ortho and para isomers. This rearrangement is known as Fries rearrangement. Similar reaction is shown by, that is phenyl benzoate which is obtained during the benzoylation. Again, they are further treated with anhydrous aluminum chloride. Then this benzoyl group again migrate to the ortho or para position, and we get a mixture of two products. Number one is ortho hydroxy benzophenol and para hydroxy benzophenol. And this rearrangement of the benzoyl group to the ortho or para position, and this rearrangement is known as Fry's rearrangement. The next is the reaction of phenol with the Grignard reagent. Grignard reagent means either alkyl magnesium halide or aryl magnesium halide. Here I am taking the example of alkyl magnesium halide. So when the alkyl magnesium halide reacts with the phenol, so in this case, this is a H from the phenol combines with CH3 to form the methane. And the remaining group is MgBr is attached to the phenolic oxygen in place of the hydrogen. Then we get a phenoxy magnesium bromide. So these are the reaction of phenol with the different reactant. And in this case, reaction shows in phenol, the OH group they react with the different substances to form a different product. So in upcoming video, I will discuss the chemical reaction of phenol due to benzene ring. Thank you.